Hey guys, just to let you know, this lesson is in collaboration with Flip Academy, a free online platform for all of your GCSE, A-Level, IB and CBSE revision, out now on web at www.flip.academy, and also as an app for Apple, iOS and Android. It really is better than all the other GCSE platforms out there. It covers all the topics in great depth and has an app that you can download your courses on and use offline. Hello everyone and welcome back to Flip Academy. So today we're actually going to be looking at integration part 1. So this is specifically the 1.8. So just as a quick aside, this was very recently updated, so 2020. They moved it from paper 2 to paper 1, hence why I've written 1.8 to be paper 1 section 8, despite the fact that the questions are going to be from paper 2 for the most part, because there's only 2 years of papers where they've changed it. So that's just a quick aside. So integration, what is it? Well, it's, as it says here, the reverse process of differentiation. So let's say I have an equation here. X squared plus x plus 1. You know, super easy. And I differentiate it. That's 2x plus 1, okay? Wonderful, right? Now, with any mathematical operation, there is always 1,000,000,000 billion% of the time a reverse operation. So when I times something, I can divide to get back to that original step. When I add something, I can subtract. When I use logarithms, I can use exponents to get them back, and exponentials, logarithms. Anything. Okay, when I take the reciprocal, I can take the reciprocal again to get the reverse. So there always has to be a reverse process, and integration is the opposite, the reverse of differentiation. So how does it work? Well, here's how it works in general. Okay, here's how it looks. You're going to have this weird snake-looking thing. Then you're going to have, I'm going to write ax to the n dx. Okay, so keep in mind, it has to be the opposite, right? So I'll show you how it works in 1 second, but just keep that in mind. And what happens here is you have ax, you add 1 to the power instead of subtract, and then you divide by the new power. Okay, so that's a key point here, okay? So before, you brought the power forward first, then subtracted 1. So the inverse of that is to add 1 to the power, then divide by it. And then you also have a plus c. Okay, you might be thinking, why on earth do we have a plus c? Well, let's have a look. If I have this 2x plus 1, and if I integrate, I should get this, right? So let's do it. Let's integrate 2x plus 1 dx. So 2x, add 1 to the power makes it squared over 2, plus, now when you have a constant, all you do is you add the x afterwards, so it becomes 1x, which is just x, right? So if I write this out now, I have x squared plus x. Now that's pretty close to this, but we're missing the plus 1. That's why we have a c. The c is something called a constant of integration. Okay, so a constant of integration. And it can take any value. Okay, now keep in mind I said value, okay? It's not a variable, okay? So it's not going to have anything to do with x, it has nothing to do with any other letter. It is a number, okay? And that's because when we differentiate constants, they vanish into the ether. So we always have to add a plus c. Now you might be wondering, okay, but what if I had y equals x squared, I differentiated it to get 2x, and then when I integrated it again, right, I get x squared. Do I need to put the plus c? Well, the answer is always yes. Why? Because if I'm being honest, if we don't know what the original equation looks like, right? We don't know what this looks like when we integrate. Okay? Because if we did, then sure, we can say that, well, c equals 0 in this case, because it's obviously 0. But to be honest, then we wouldn't have to integrate, would we? I could write, okay, I'm going to integrate this and just write the equation, because that's what it would give me. So in all cases, you add the plus c, except for one case we're going to come on to a while back. But whenever you integrate, 100% of the time, put plus c. Okay? Because, again, c could be 0, could be negative 1,000,000, it could be plus 35 over 2, it could be anything. But we don't know what it is, you have to have the plus c. Now, in a question, if you do this kind of integral here, and you don't put plus c, you'll drop a mark. So put it. This thing here, if there are no numbers on the top, so 2 and 1 for example, if there are no numbers, it's called an indefinite integral. Okay. So, I'm not going to explain anything else about integration just yet, until we need it, okay? Because I think that would be the most useful thing for me to do for you. But this is what we're going to do for now, okay? So again, there are 2 extra things with integration about what it gives you, but we're not going to go through them just yet. The last thing I'm going to say is it says, for any value of n except minus 1. Well, let's have a look at that. If I have x to the minus 1, and I were to integrate it, let's see what happens. If I used this rule, if, I would get x to the power of 0 over 0 plus c, which is obviously not right. So the only value it doesn't work for is minus 1. For every other value except minus 1, you can use this rule here. Okay? The reason for this is this actually equals ln x. Right? And hopefully you should realise that when you differentiate ln x, you get x to the minus 1. You get 1 over x. When you integrate, you should get the same thing back. But yeah, that's it. And again, we're just going to get on with some questions, and I'm going to explain it as it comes up, so I don't overwhelm you with a bunch of information that doesn't have any context. So, the first question, and the first 2 spec points, is solve problems involving the evaluation of a constant of integration. So what that means is that when you get a plus c, you need to be able to work out what that plus c is based on information in the question, okay? You need to be able to do that. That's all that means by solve problems involving the evaluation of a constant of integration, okay? Basically means work out the constant of integration. And the second bit, evaluate definite integrals. Well, I said that these are indefinite if they don't have limits, so numbers here and here. If they do have numbers there, they're called definite integrals, and I'll explain what that is in a couple of questions. So find an expression for y in terms of x. They've given you dy by dx, and they've given us a point. Well, first things first, y would just equal the integral of 10x to the power of 4 minus 5 dx. And so when I integrate this using my rule, I get 10x, I add 1 to the power to make it 5, and divide by the new power. And then minus 5, since it's a constant, I'm just going to shove on an x, and then never forgetty the plus c, never forget. So if I simplify this, I get 2x to the power of 5 minus 5x plus c. Now, of course, it says find an expression for y in terms of x. At the moment, I've got it in terms of x and c, so this isn't correct. But they give me a coordinate. So to work out the value of c, when you work out y, the equation for y, you have to have a coordinate. You have to sub in that coordinate. So we can write x equals 2, y equals 30. So now we have 30 equals 2 to the 5 minus 5 times 2 plus c. And again, if you want to be really lazy, in which case I most certainly do, we can use a calculator for this, or whatever, or you can just use the fact that you should know that 2 to the power of 5 is 32, so this is 30 equals 64 minus 10 plus c, so 30 equals 54 plus c, so c is equal to negative 24. So that means our actual equation is y equals 2x to the power of 5 minus 5x minus 24. So that's what they mean by evaluate a constant of integration. Okay? Just need to work out what it is, which means you just need to have a set of coordinates, and you should be all fine. Now, the definite integral thing. This here, I want to show you how to evaluate it, and then I'm going to tell you what it means, okay? And I'm going to tell you what it means using an example question a bit later on. But for this question, we're just going to evaluate. So what do those things mean? Well, the first thing you do is you need to expand the brackets, okay? And these numbers don't mean anything just yet. So we have x squared, and then we have plus 4x minus 3x, so we have plus x minus 12 dx. And now I'm going to evaluate the integral as per normal. However, I'm going to put massive staple brackets around the whole thing. X to the power of 3 over 3, so I'm going to write that as 1/3 x cubed. Again, I added 1 to the power and then divided by the new power. X to the 1 will become x squared over 2, which is a half x squared. And then we get minus 12x. And I'm going to write the plus c. Now I'm going to close these brackets, I'm going to write the limits again. So, what does it mean by definite integrals? Well, a definite integral is always going to give you a number as an answer as opposed to an expression. Okay? Now, this expression actually gives me the area between a curve and the x-axis. So, when you put this value in, when you put these two limits in, you're actually going to get an expression for the area between a curve and the x-axis. So, just to give you a bit of an example here, this could be something like... So, I actually don't know what this looks like in actuality because I haven't bothered to check. So, let's say 1 and 3 here. Okay, and that would give me the area between them. Right? Likewise, if this was, let's say, -2 and 1, integrating between -2 and 1 would give me this area. Okay. Now, there is something quite weird that might happen, is you might get a negative area, and you might think, well, that doesn't make any sense. Areas under curves are always negative, and the areas above curves are always positive. Remember, it's not... So some people say that when you do definite integrals, it's the area under the curve. It's not under, right? Because this part here isn't under, it's above. It's the area, if you want the really technical term, it's the area bound by the curve and the x-axis. The way I like to say it is the area between the curve and the x-axis. That's it. If it's above the x-axis, it's positive. If it's below, it's negative. Okay? So this is going to give us a number. That number is the area. Okay? So now what we're going to do is sub it in. So what we do is we first take this whole expression and sub in 3. So we have 1/3, 3 cubed, plus a half, 3 squared, minus 12, 3, plus c. And then what we do is we subtract the exact same formula, but when we sub in 1. Okay, so if you like, when we integrate, it actually gives us an equation for the area. Except if we don't sub in limits, it's from -infinity to whatever value we've picked. Okay. Now, if you notice, this plus c goes away. And if you're really on it, you might notice that that plus c is always going to cancel 100% of the time because it's never going to have an x, right? Which means it's never going to be affected by the bounds. This is the only case where you don't have to write the plus c. You don't have to write the plus c if you're doing a definite integral because it always cancels out. And then all you need to do is sub the whole thing onto a calculator, or again, you can work it out or do whatever you want. But if I were to use a calculator, it'd be minus 34 over 3. And again, make sure you use 2 layers of brackets to make it super clear, make everything nice and easy. Okay, so this would be the area between the curve and the x-axis. It's negative, so it would be a underneath the curve. Okay. So, oh look, it's the thing I just said. Use definite integration to find the area of a region bound by a curve and the lines parallel to the axis. So in this case, the x-axis, and a line between, and a line or between 2 curves. And then also something called a volume of revolution. Volume of revolution I'll come on to in 2 seconds when it actually comes up in a question. But let's go with this as our question here. So first of all, it just says write down the values of x where the curve crosses the x-axis. Well, that's when y equals 0, so that's going to be at x equals 0, x equals 2, x equals 5. So I can write 0, 2, and 5 here. Okay. Part B, find the area of the shaded region. 8 marks. Hot damn. That's pretty big, right? So, again, these questions are pretty tricky. They're pretty long, which is why they give you such a ludicrous amount of marks. But let's think. Okay? You might be tempted to integrate this between 0 and 5, and that will give you the area between the curve and the x-axis. Yeah, that's kind of what I said it would happen, but I actually said something else, right? This is positive. This is negative. If you integrate from 0 to 5, you are going to get that part of this area is going to cancel with this area. You're not going to get the full value. Okay? What you need to do is you need to integrate between 0 and 2, then 2 and 5, but you take the modulus, the magnitude of it. You make it positive first. Okay? So you need to integrate twice, which is why this question is slightly trickier. Okay? You cannot do from 0 to 5 because the positive part and the negative part will cancel. The overall number will be smaller, right? Let's say this is 2 and this is -4. It would tell me that the total area is -2. That's not right. It would be 2 plus 4, which is 6, because areas cannot be negative. Okay? So, let's go through it. First of all, we need the actual equation. We can't use that factorized form. So we're going to have x squared minus 2x minus 5x is minus 7x, then plus 10. And we're going to expand the bracket once more. X cubed minus 7x squared plus 10x. And again, we're going to integrate this 2 times. Okay? Now you might think, oh, that's kind of weird. Why would you integrate it 2 separate times? You don't have to, actually. You can just integrate it once and reuse what you will get. So the first thing is we're going to integrate between 0 and 2, which, just as a reminder, is the 2 x-intercepts here. So I kind of picked the worst possible value for that, didn't I? So yeah, let's clear that up a little bit. So 0, 2, and 5 are our x-intercepts. And we're going to integrate this between those values. So, again, do it nice slowly. Again, this is an 8 marker, so hopefully you've got some snacks ready, because this might take some time. And I'm hoping that me doing this and like kind of skipping over adding one and like doing it nice and neatly makes a lot of sense. Because it's not too bad. And again, I'm not going to write the plus c. I'm going to do something a bit naughty, not do it. So again, just so you know, add 1 to the power, divide it by 4, so that becomes 1/4. Add 1 to the power, divide, so 7/3. And 10 divided by 2 is 5. Advanced maths, right? Now 2 and 0. Now here we can use massive brain tactics, okay? So what we can do is, I'm going to sub in the 2, obviously, because that's what we need to do, and yada yada yada. Right? But, do you see why? All of these terms have x in it. So if I sub in 0, the whole thing's going to go away. So I only actually need to sub into the first one, which makes life ever so slightly easier. So if we get out our calculators and type it in, we're going to get a value of 16/3. So just to save time, I actually do have the I have a calculator in my hand instead of doing it on screen like I normally do, just to save a bit of time, because otherwise it'd be a bit tedious. So that's my first part of the area, okay? The second part is I'm going to integrate again, but from 2 to 5. So realistically, all I'm actually doing is subbing in 2 new sets of values, right? I'm not actually integrating, because obviously I'll get the same answer, right? But I'm going to sub in brand new limits. And it should be noted that it's not just the smaller value that goes on the bottom. It's just you're reading from left to right. So 0 to 2, 2 to 5. You're reading from left to right, okay? The one on the left goes on the bottom. If you want, if you swap them round, you'd get the wrong sign, right? So if I did from 2 to 0, I'd get negative 16/3, which isn't the worst thing in the world. But yeah, that's a whole other thing. Don't worry about it. You don't ever have to, like, you don't have to do it, but in order to save, like, changing the sign, you can change the direction of the limits. I don't find that to be particularly useful, because I can just make it positive instead, and, you know, it kind of just saves a little bit. And again, this is going to be the tedious part. There's also kind of a question that I get occasionally, and this is because it's somewhat recent, but this black and white calculator here, the one that I always have on screen in all of my videos for you guys, it actually does have an integration button right under the menu, right there, okay? And it has limits too. So the natural question is, well, can I just use that? The answer is you need to show some of the steps, right? I can't just use that button twice and then add them together and get the full marks. You have to actually show some steps. So I'd recommend just writing it out. I know it may seem a bit long, but then what you can do is use that button on your calculator to double check answers. That's what I would use it for personally. Again, the calculator that I used when I was doing the A-level maths exam didn't have that option. The other thing I will note is that typing things into a calculator is actually somewhat tricky. So I've seen students do it wrong using the calculator. So you would need to have some practice with that first. Don't just say, yeah, in the exam I'll do it. No. If you're going to use that button, use it to check, 1, and 2, practice using it. So if you want, check all of your answers from now on to your exam with that button so you know that you're definitely good at doing it. That's minus 63 over 4. So of course the actual area, right, so now I'm going to write area is equal to 16 over 3 plus 63 over 4. Again, I knew just from looking at the graph, the second thing would be negative and it would be bigger, right? Which it is. And that gives you an answer of 253 over 12 once you add them together. Okay. So yeah, I know these questions have been mighty. They've been truly hefty ones. But we have one other style of area question, and then we have a volume question, and then that should be it for this one. Okay. So, in this case, we have a curve and a straight line, y equals 2x. Find the coordinates of the points where the line intersects the curve. So, we have this shape here, this shape here. You can probably already see, because this is shaded, we're going to be asked to work out the shaded region. Don't worry about it. It's all good. Everything's easy peasy lemon squeezy. Work out the coordinates point where it intersects the curve. Okay, so all you need to do here is you need to equate the two lines. Subtract 2x on both sides, we get 8x. So x equals 0. Now, actually, I'm going to go back a step. Right. Factorize out an x, you get x, and then 8 minus x equals 0. So the two coordinates are x equals 0, and well, not the two x coordinates, I should say. And x equals 8. If x equals 0, then y equals 0 if I'm using this equation here. And if x equals 8, then y equals 16. So the coordinates are 0, 0, and 8, 16. I'm really proud of that ampersand I just drew. That was really smooth. Find the area of the shaded region. Okay, so here's how I would do it. And I'm going to show you the slightly longer way and the shorter way. Okay, there's a few ways to do this, right? That's a big old right angle triangle. So you can work out the area of the triangle, integrate under the curve, do the integral of the area under the curve. So you take this integral here, between 0 and 8, of 10x minus x squared, and then you subtract the area of the triangle, which you can either do kind of half base times height, or you can do integral of 0 to 8 of 2x, right? That's what you can do. So I'm actually going to write it out properly. It should be, and this is just to make it 100,000% accurate, 10x minus x squared, and again make sure you get this the right way around, minus the integral from 0 to 8 of 2x dx, okay? That is what you should do. You can use the area of a triangle, but keep in mind that it can sometimes be difficult to spot what shape it is and things like that. Now, you might be looking at this, rolling your eyes into the back of your head and saying, I really have to integrate twice? Well, for those of you who are of a little more lazy persuasion, or more efficient is what I'm going to call it because it makes me feel better about myself, you don't have to integrate them separately. If you look, we have the exact same limits, and we're going to subtract them anyway. Why don't we subtract the equations now? And indeed, this is 100% equal to 0 to 8 of 8x minus x squared, because all I've done is I've done 10x minus 2x. So, the reason why I mention this now is because sometimes they have brutal questions where they have one curve and then they have another curve, right? And you have to work out the area between them. And then you're integrating like a cubic and a quartic or something, and you're like... But you can subtract them. So these two things here are exactly 100% identical, and they're also identical to the half base times height method as well. So I would just do this, but that's because I am slightly lazy. And add 1 to the power, divide by the new one, so we have 4x squared minus a third x cubed. And we're subbing in the values of 8 and 0, which is squared. And then, of course, since we're subbing in 0 into something that only has x's, 0. So, again, I would like to point out, this is not always 0. When you sub in 0, it doesn't always make it 0. Only if every single term has x. Sometimes you might have an equation that has like a +1 or a +2, in which case you will hate yourself when you sub in, when you say it's 0, because it's not 0. Okay, and then using your calculator, we can work this out. I could do it in my brain, but my brain hurts. 256 over 3. And like I said, if you want, you can test it the other way. Test it both other ways if you want, and show that they're all equal to each other, just to keep that in mind. Now, you may notice that there are no more questions. However, there is one more topic that we haven't gone through yet, and that is the topic of volume of revolution. So there are certain questions that you may have where they talk about, calculate the volume of revolution about certain things. So I'm going to write that out for you now. So, volume of revolution. Okay. This is a bit of an obscure thing that will come up more if in university you decide to do like engineering or physics or something like that. But essentially what they're doing is they take the shape and make this 3D in your head, and they rotate it 360 degrees. Right, so if you try to imagine it as best you can, right, it doesn't really matter, right? I'm just going to show you how to do it. But the key point here is you either rotate it around the x-axis or the y-axis. So in this case, you either take your U shape and you rotate it this way or this way. That's it. Again, don't worry about the general principle, right? But the way to do it is, if it's around an x-axis, so if they say rotate around x-axis, the volume is just, again, you have your two limits. You have to have limits, right? Because just like area, I can't work out the area without limits. Otherwise, I'm just going to get an equation, right? And instead of just the equation, you're going to have pi times y squared with respect to x. And if it's the y-axis, all you do is you swap x and y. So what I mean by that is everything is identical, so a and b, pi x squared dy. That's it. So if I have my equation, I'm going to go through an example in a second, and it says I'm rotating about the x-axis, I sub in whatever my thing is for y, I square it, times it by pi, and that's it, and integrate with respect to x. If it's about the y-axis, I have to, instead of having, let's say, y equals x squared, I would have to have x equals the square root of y, and sub that in instead. Okay? And then obviously you're integrating with respect to y instead of x, because there won't be any x's in your value. So as an example, imagine we have the graph. In fact, you won't have to imagine, I'm going to write it out for you. Graph of y equals x squared, right? And from, or between, x equals 1, and again I've got this example written down in front of me, which is why I'm saying this. And they always give you the look of the graph, the shape of it. They won't, unless they've asked you to draw it in a previous part, they won't expect you to draw it. And it's rotated completely around x-axis. Okay, so so the reason why I'm doing this in this kind of format instead of my usual format, finding exam questions and stuff, is this topic, as I said previously, was in paper 2, and in paper 2 there's integration that you haven't done yet, like integrating exponentials and cos and sine and stuff. So effectively, unfortunately, your actual questions, it won't just be x squared, or at least it could be, but I didn't find any. I could only find ones that had sine, cos and tan in it. So I have to make my own question and example, okay? Find volume generated, right? And in case you're interested, if you were to draw the graph just from like x equals 1 to x equals 3, it would look something like this, right? So it's a big U shape, right, normally, and it would go through the origin, but again, it's only from those two values. So all we need to do is, it's rotated by the x-axis, so we're going to use this top equation here. So volume equals the integral. What are our limits? Well, 1 and 3. Pi y squared. So pi times x squared squared dx. So 1 and 3. Pi x to the 4. Remember, you do have to times the powers in that situation. That equals pi over 5 x to the 5, and we're going to sub in 3 and 1. Okay, so it just shows a fairly rudimentary example. But again, there isn't actually anything special about this, okay? So it's actually not that bad. It's still just integration, right? Normal run-of-the-mill integration. It's just that it has one extra step, which is timesing by pi and squaring. But that shouldn't actually make any real difference to what you're doing. So it's not, in my opinion, that big a deal. And we get 242 over 5 pi. That's it. Okay. Just as a bit of like trivia, the reason why you always have this pi is you always have a curved shape when you spin it round. So even if you took, for example, y equals x, right? So you have a straight line. If I were to rotate that around, can you see it'd be two cones stuck together? So that's why that would be that way. So that's all there is for the first part of integration. So I hope to see you in the next one.